All right. So you guys like my... Do you get it? Probably. Probability. No. Not funny. I tried. This time I was trying to find a meme for every slide or for every lesson. So, personal goals, right? I aim high. Okay. So, you guys got a little bit of a chance. Hopefully you read the chapter 21. How did Friday go? Went okay? Hopefully you actually read the chapter. I'm seeing some faces that are indicating otherwise. But because of that, I'm not going to sit here and wait for you guys to copy notes. I'm just going to go over it, and my real focus here is to get to practice. Now, last flex, we talked about we talked about how to use the calculator to do this stuff, and you're going to see why the calculator was so good. Yes?
The chapter 20 homework.
Uh-huh.
A lot of us, including Chris, were wanting to talk to you about this on Friday.
Yeah.
But there was stuff about t-values and things like that.
There were t-values on that?
Yeah. So there were a couple of questions where I just...
There were t-values on that?
Yeah.
I will go back, take a look at that, and try to figure out what the t interval?
Yeah. It was a lot of fun.
Because, no. A t... Okay, I don't understand why they've done that, because that's not covered in the textbook yet. That's not covered in the textbook until, chapter 22. So, yeah, awkward.
And part of integrating, binomial PDF.
Integrating?
Yeah, there was a problem where you had to, work in binomial, right?
I will go back. It's been a while since I checked that homework assignment, so I will go back, and I will, if I need to kick out a couple of problems and replace grades with whatever they are without those problems in there, I'll do that. I'm sorry. I do look at the questions. I guess I don't look at them close enough. So, might be. Thank you for bringing it to my attention. Okay? All right. So, what we're moving on to now is comparing two proportions rather than just looking at one. And it's a very subtle difference, because when you could kind of think about it as your null hypothesis being the proportion you're comparing it to. But for this chapter, the big thing that you have to look for is that they specifically, physically, give you two different sample sizes. That's the big trick here. One group is this size, another group is this size. They might be the same size, but you are told the sizes of two groups, not just one. That's how you can tell that you're comparing two proportions. Okay, now this is much more interesting, because it's not always that we're going to say, hey, is the proportion the same between what it used to be? Because that means I have to know what it used to be. So instead what we'll do is we'll often say, okay, this is a sample I took 10 years ago. This is the sample I took today. Let's compare those two samples. Because I don't really know exactly what's true 10 years ago. I don't really know exactly what's true today. So we're trying to use these two samples to compare. Okay? Or maybe we're taking a sample from one university and a sample from another university, and we want to look to see, is there a difference in, for example, their female acceptance rates between the two schools? It's a lot more interesting that way to compare two groups rather than just look at one group. But the problem here is it's very important. You have to be very clear about your context. So in this case, rather than having just one P, you're going to have two. So the way I normally do it is I define P. P is the proportion of women. But then I will define my groups. I will either say group 1 came from UVA, group 2 came from Virginia Tech. Okay? So I'll say 1 equals UVA, 2 equals Virginia Tech, and I'll say P1, P2. You have to be able to clearly tell which is which. If you're talking about men versus women, M and W is kind of an understood notation. And if you're using understood notations, then you don't have to define them. If you're talking about group A and group B and you use A and B, you're pretty good. You don't need to go anything crazy. But you're still defining your P. Then you define what your two groups are, and you have to show a very specific order. Because if I'm thinking that more females are accepted at UVA than at Virginia Tech, then the order that I put my two, I don't know if that's true or not. Is it? No? Virginia Tech accepts more women?
Virginia Tech has a higher
acceptance rate?
Yeah.
Okay. So, she's like, I don't know. Virginia Tech has a higher acceptance rate? Is that what you just said? Really? I just learned something new. I would have thought it was the other way around. Liberal arts schools usually have higher. But anyway, it's okay. So you've now very clearly gotten my brain on a completely different track. Okay. So you have to show order, because depending upon what order you put it in, if I say cats are better than dogs, if I do cats minus dogs, I should have a positive number. If I do dogs minus cats, I should have a negative number. So that's very important that you're always clear as to which group what order you're doing it. And so here is an example. If I'm going to be comparing like final grades between two teachers, I would say P is a proportion of students who earned A's. So what is it that I'm talking about? Then I would define my groups. So I would say either group 1 or 1 is Scrooge, 2 is Wimpy, because this like kind of goes back to the problem we had in the very beginning, which you've probably forgotten about. And then you would talk about, for my null hypothesis, you would set which your order is. And for us, for this class, the null hypothesis is almost always, for a difference in proportions, going to be 0. Now, the alternative being equal, not equal to, greater than, or less than, that will change. But generally, what we're talking about, is there a difference? And if there isn't a difference, if there is no change, then when you subtract those two proportions, that should be equal. But again, identify P just like we had before. Talk about your two groups, what they are, and define the order. Yes?
Is something a question like that, there's not necessarily a context indicating which should be bigger?
Right. If they're just looking for any difference whatsoever, it doesn't matter, because your alternative is going to be not equal to. The one that matters is if I think that Mr. Scrooge's classes are less than Miss Wimpy's class. So if Mr. Scrooge's are less than Miss Wimpy, then when I do 1 minus 2, I would expect a negative number. So my alternative would have been less than. If I did 2 minus 1, it would have been greater than. So it's more about when we're looking to see if the change goes in a specific direction. Okay? But other than that, this is just for that sake at the end. Okay? For the alternative. All right. Now, this should have been pulled from the textbook, very straightforward. When we're talking about the standard deviation of the difference between two sample proportions, it comes from the idea that if I'm talking about one group and I want to add to it another group, remember combining my random variables when we're doing this? We said for that, if I wanted to talk about the standard deviation of those two groups added, we couldn't add standard deviations. What could we add? We can only add variances. So that would have been the square root, because these are variances, of the variance of x1 squared plus the variance of x2 squared. Okay? And remember, when we're talking about proportions, no, standard variance is the standard deviation squared. There we go. When we're talking about proportions, the standard deviation is root PQ over n. So putting all that together, my first group's standard deviation squared, PQ over n, plus the second group's, and then take the square root of that whole thing. But pay close attention to this, because when you actually go through, like, even though we're going to be doing most of our computations in the calculator, you still have to denote the formula. And so you would need to put your subnotations. All of this is group 1. So this is success for group 1, failure for group 1, size of group 1. Success of group 2, failure group 2, size of group 2. Okay, and then just remembering back from our combining random variables stuff. Now that's the standard deviation. We use the standard deviation if I know what's true about proportions. If we know what's true about the population, we'll go with standard deviation. Otherwise, we call it standard error, and we use P hat. Wow, massive change. Standard deviation, if you happen to know what is true about the populations, we generally don't, so usually we use standard error, and we talk about P hat. Okay? All right, so go ahead and read through this problem, please. One of the things I like most about our textbook is that it actually does take, like almost all of the data that they use is real life data that they've pulled from sources, and they actually cite all of their sources, which is super cool, because I'm a nerd. All right, I'm going to show you, right now we're just talking about the standard error, but I'm going to show you what I think is important and how I write these things down. Okay, ready? So the first thing that I do, what did I say you should do first? Identify what? P. So I'm going to start by identifying what is P. The proportion who are foreign born. Should I put Canadians in there? No. Should I put Americans in there? Why shouldn't I put those guys in there? Yeah, those are my groups. So I'm just going to be putting for P the proportion who are foreign born. Ah, shoot. How do you spell foreign? I stink. Where's my foreign? F-O-R-E-I-G-N. I teach math. Thank goodness for that. Proportion who are foreign born. Now, it's your choice as to how you want to identify them. I think about it, and I say, let C be the Canadians. You know, those folks from Canada. And let's do U be the U.S. born. Us. Or just U.S. Okay, sometimes they'll see C-A-N, sometimes they will write subnotation U.S. But for this question, asking me to find the standard error of the difference. Now, there's no real specification in this problem. If I go back to it here, that's not going to let you see it. If I go back to it here, like what order to do, so just pick an order. And for me, I go with the order that they gave me things in. They gave me Canadians, and they gave me Americans. So what I would do here, actually even before I start my standard error, I would say P hat for the Canadians is what? $192 over 960, and I would say P hat for the US is what? Okay. All right, so let's pull this back up so you can see. So I'd write those down. I would do my Q hats also, and you see I use my little subnotation here. So if this is P hat, what's Q hat? You can use a calculator. It's okay. Starts with a 7. 768. And for Q hat, for QU, starts with a 1. $10.80. I'm sorry? Yeah. And if you want to write this down here, you can. The total sample size for the Canadians was 960. Total sample size for the US was 1250. I label all of my bits and pieces. That's the way I do it. I do it there because I know that those values will come all over the place. So why not just stick with them up front? Now this question said to find the standard error of the difference. Now simply because they gave me this one first and then this one, I'm just going to do the sample of Canadians minus the sample of the US. But that order there is important because when I fill out the order for my formula, I need to make sure that I put them in that order. And so for the standard deviation for this, I would do P, Q over N. And variances, even though it's just a minus sign here, we only ever add our variances. So then we would have P, Q over N. Okay, do me a favor, type that into your calculator. Take it out to 4 decimals. Give you a hint, it starts with a 0. Hee 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 hee. Do the hard stuff for you. Isn't this fun? Eden, what'd you get? It is not as easy as you might think to type this in, so check to see that you got 0.0161. This is an ugly looking fraction. And I will say, I think it's easier when you're doing stuff like this to do the, let's see here, second square root. I use, oops, it's not that button, it's the alpha y equals. I use my pretty fraction, and I do that because I can put a pretty fraction in a pretty fraction, and I can do 192 over 960. So, but I like doing it that way because I can tell where all of my parentheses and everything lines up. But how'd you do with that? Were you able to get that? It is not the easiest. It's so simple to make a typo when doing that. All right, cool. Let's go back to this. Alrighty. So we have this information. Okay, that was my first setup, is I wanted to go through and do this. Now, I don't believe we did, we'll come back and talk about the assumptions and conditions, but look at what they gave us. They gave us a confidence interval of this right here. When we're calculating the confidence intervals for these guys, they are ugly. So go back to your calculator. Hit your stat tests button. By the way, ladies and gentlemen, this is very important. Do not, in this class, use z-test or z-interval. Okay? They're still in there. That's an old statistics belief where they thought that would, like once in a blue moon be appropriate. Very rarely. So don't ever use z-test or z-interval. And right here, we're doing a z-interval, but it's a 2 proportion. And make sure you go to the proportions. So go to the 2 prop z int. Now for my calculator, what I'm going to do here, x1, you see how I have all of my first group here? x1 is the numerator for P1, n1 is the denominator. integers only. If you put a decimal in any of these x's or n's, it will give you an error. Group 2, that's my successes. That's my totals. And the problem that they gave me a 95% confidence level. So let's just make sure our answers match. There's my confidence level. My confidence interval. So if you look at that versus what this problem right here says, do they match? Where is it? Here it is. Do those numbers match? They're very, very close. And the issue here is whether or not they rounded, how they rounded, where they stopped rounding. So, no, they did. Okay, so it's rounded out to here, so that's good. All right, so what I want you guys to do is I want you to write down on your paper and interpret the 95% confidence interval and the 95% confidence level. Okay? You are in a classroom with hints. So, my interpretations coming from this sucker, let's see here, where's my little dude? There he is. So here's what I have. First off, this is for my confidence interval based on our samples. Because it's not just 1, it's 2. If you left the S off there, probably wouldn't get you anything. But you do have to be clear, so like those little things indicate the difference between 1 or 2. We are 95% confident. There's my confidence level. The true difference in proportion of people foreign born. Notice, I have to have this guy right here. That is hugely important because if I did US minus Canada, it would have been negative 9.56 to negative 3.24. So that order there is hugely important. So what we're looking at here is the true difference in proportions and then identifying which direction I did that subtraction. Okay? Lies in the interval from to. Okay, those are, and then of course a little s here, those are the main differences that we see in the difference interpretation. We see the same thing in our interval level, again, with repeated samples, that's still there. 95% of the 95% confidence intervals should contain the true difference in proportion. Bless you. That's not really a bless you, but bless you anyways. And then I specify Canadian minus US. I didn't know if I should write Canada minus US or Canadians minus US. I don't know. Whatever. And what this goes to is when we're looking at our confidence interval statements, it says the true population parameter. And the parameter here that we're interested in is not just proportion of foreign born, but we're interested in the parameter of the difference in proportions. So that's why you kind of have to think about that whole guy as being one thing. Okay. How'd you do with that? Just curious, because I didn't tell you to do this to start with. How many of you wrote the order that it was subtracted in? Just a couple people? That's okay. I want you to make note of that. Go back in on the side and say, make sure to indicate the stuff. When you do something like that, you're actually more likely to remember it the next time around. Because you're saying, hey, I missed something. This is what it is. Let's not do that in the future. Okay? Now, yes, sir. Foreign. Because, I switched the G and the N. Foreign. It's foreign. Kind of like boring, but before. Jeez, thank goodness for erasable pens. I don't know what you're talking about. Everything up there is spelled 100% correctly. Yay! So we are missing a few things here for the entire process. Did I screw up again someplace? Candian? They're Candians, apparently. Jeez Louise. We're moving on. Stop picking on me. There's actually things in this problem that we didn't do. Obviously, we didn't show the calculations that are required for an individual confidence interval, but we also didn't check assumptions and conditions. I heard that. The thing with this, though, is they're the same assumptions and conditions? Good morning, people. She sells seashells down by the seashore. How much wood woodchuck could chuck wood? Just go with it. All right. So when we're looking at this, what were my conditions for proportions? Give me one. What's my big assumption? Independence. So sometimes you'll be able to state that. And the one thing that we add for this is the independence of groups. So the proportion of people foreign born in Canada affect the proportion of people foreign born in the US. I mean, sure, if you want to kind of like argue it, I'm sure you could come up with a way, but we're just going to assume they're independent. And then what you do for this is you go through and you just check your assumptions and conditions for both groups. Okay, so independence. Independence, we have sample size. So that means that my 10% population, I don't remember what my sample sizes were. What are my sample sizes? So 960 is definitely less than 10% of all Canadians. There are a few more than 10,000 Canadians out there. And 1,250 is less than 10% of all US folks. I mean, that's less than we have in this one school. So there's that. Okay, then we have the success and failures. All of those are the same, but I want you to look at this. We need randomization. We have independence for the groups and independence within each group. So that's what we're looking at here. And we're going to come back and look at that a little bit more specifically. Right now, we're just saying, what are all the interpretations from before? How do they fit in with what we're doing now? So, read this. And it says, is it reasonable? But I also want you to go through and I want you to write down, physically write it down, the interpretation of that p-value. So is it reasonable to believe? And then tell me what that p-value represents. With words. I'm questioning everything I spell. a lot of people that haven't written a thing down. The goal with this, I know it's tedious to write this stuff down, but there's a point where it actually becomes muscle memory. And you don't have to think about it as much. And you don't have to constantly swivel your heads over to look at the board to find what the interpretation of a p-value is. Okay? So the act of physically writing this is a huge, huge help, especially when the goal is strictly, in this case, memorizing. Okay? So my first question is it reasonable to believe the ads may be effective? Why? Okay. Now, did they give me an alpha? No. If they don't give me an alpha, what am I going to compare that p-value to? 0.05. Okay, because that's just the given. And with this, the way I wrote my answer, and the thing that you need to be very careful with, where is it? Here it is that it may be effective. Don't tell me the ads are effective. Okay, there are a lot of different reasons why all of a sudden that candidate's name might be well known. Maybe all of a sudden a massive conspiracy theory came out. He's all over the news for that. Or some slander from another player became a part. Might have nothing to do with the ads. All I can say is that there probably is a change. Yes, sir. I did not mention random sampling. Through random sampling variability. He does this thing where he just keeps the level eye at you, like going, no, you're horrible. It's like, how do you do that? Okay, yes, through random sampling variability. Thank you. Okay. And what this kind of goes on to say is that, in a different sample. So they mentioned the sampling variability here. Okay, so our assumptions and conditions. Please look. These are almost exactly the same thing as what we had for regular proportions. There is differences in here. Find one. Independent groups. Not only does all of my data still need to be random and less than 10% of the population, but the groups themselves must be independent. And that is one, like if they're doing a question about this, if you don't specify independent groups, that is one of the ones that will automatically take you down from a 4 to a 3. Okay, this is extremely important. If the groups are not independent, this does not hold. There is a whole other series of statistical tests that we do for non-independent groups. Okay, that's not this class. And then if you look here, each group must be big enough. So when I'm doing my work, typically the way I will do this, and I'll show you that in a second, but if we go back to the examples that I've already done, if I'm listing out my bits and pieces, I will sometimes make a line on my page, and I will say this is all, I will say the top C is Canadians, and I will do all the Canadian facts. U is US, I would do all of the US facts, and under Canadians, I would check my assumptions and conditions. Under the US, I would check their assumptions and conditions, and then at the very bottom, I would say groups are independent, or assume independent groups. I would say something along those lines. Okay, because I'm organized, and I find that being organized kind of helps me. Some of y'all might not help very much. Okay. So let's start with this. Read through this problem for me, please. Read through this problem. I'm telling you right now, the test would not be appropriate. Can you determine why? After going over what the assumptions and conditions are. Yes. Yes. And the question that she's asking here, guys, is she's saying, okay, are they going to give me a problem like this and leave out that last thing and say, just do the test? Just do the test. Well, this is where the real world comes in. Your boss out in the real world is sometimes going to tell you, do this. You're going to look at him and go, are you nuts? You can't do that. But your boss is your boss. So you can do what your boss tells you, even if you know from the beginning that it's not going to work. You try to make that argument from the beginning, but then you go through and you do it. And then at the end, you say, excuse me, careful with the interpretations of these results. Assumptions and conditions were not met. Why? And she's like, perfect. I will be honest with you. When I have seen that happen on AP exams, it's usually you're given a lead. At the end, they'll say, do the assumption. They'll say, do the test. At the end, they'll say, what problems come with this? Do you understand what I'm talking about there? So whether that's your success failure condition wasn't met, or your 10% condition wasn't met, or your independence or independent groups were not met, it'll give you an opportunity to do that. And as we go through and do this, you're going to see the very first thing that you want to do, just like in any problem, is read the whole entire question, not just one little blippy at a time, because sometimes the question will kind of say, it's okay, they know it's crazy. Okay? All right, so why would this test not be appropriate? Yes. There's only one population. Okay? If we're looking at that 44% and the 29%, they came from the same group of people. So in my assumptions and conditions, what does that nix? Cross out and say, I don't meet that condition. The groups are not independent. Let's think about the question. And let's change it up a little bit because we're a little bit different of a world now. We've kind of known. Yeah, email addresses, phone numbers, things like that. How many of you guys are willing to share your Twitter account or social media handle? Okay? Like with perfect strangers. Okay? Lower your hands. How many of you guys would be willing to post your email address on your social media account? Apparently Cameron does.
Business email, yes. Personal email.
And just a little bit of a lesson to you guys. Unless you know the person, don't give them your email address. What? The reason why is there things out there that will filter through and just look randomly for email addresses and send out viruses, your spam box will explode into thousands of annoying, disgusting pieces quite often. So, and then you never know what kind of scams go out with that. But I mean, how many of you would give out your cell phone number? I see a couple people going, oh, nobody else is raising their hand. Okay, and it's things change. This textbook came out 4 years ago. And already it's not about emails and cell phones, it's more about your social media handles and your emails. It's like we've grown a step. Okay, so we do not have independent groups. How you respond to the first question probably has some effect on how you respond to the next question. If I ask you, do you lock your front doors every day? That might affect, do you have a security system? If you don't bother to lock your doors, why would you have a security system? Do you see how those two kind of play involved? And you're right, you can tell here there's just only one group of randomly selected teens. If they took that group and they split them up and randomly assigned half and half to a group to answer each of those questions, then yes, I could have said independent groups because they were randomly selected to the questions. But we don't have that in this case. And with this, we come full circle back to the very first unit that we did, which was the collecting of data. So if you look at this, we talk about errors, we talk about what sampling design, all of this comes back and bats you in the boom. So read through that problem for me. There's a lot going on here. Try not to fall asleep by all those words. All right, so let's think about this. Sampling designs. What are the different ways I can sample things? Simple random sample. Cluster. Stratified. Systematic. Convenience. There's one more. Well, that's not a sample, that's everybody. That's multi-stage. A combination of those. So again, we have simple random sample where the only thing we are doing is randomizing. Bless you. We have convenience where I go there and I just get folks. What is the difference between cluster and stratified? All of some and some of all. So which one is all of some? Cluster. Think of your grapes. When you go to the grocery store, you buy a cluster. You buy all of some bag. What is stratified? Some of all. You get some from each group. So looking at this, what sampling plan did they use? Say it again. Stratified. What did they stratify by? And so with a problem like this, you need to make sure that when you're answering this, you would literally say in the answer to this, stratify by gender. Do you understand what I'm talking about there? Stratify by gender. Okay. What difference would you expect the poll to show? What would you expect it to be? Take a guess. Percentage-wise. Give me a number. Where did you come up with 6? But why that number? Because it's the difference of what's actually true. Do you understand what I'm talking about here? The difference that we get from our samples should be the difference, or at least centered around the difference of what's actually true. So what they did here is if I were to do males minus females, I would expect a 6% difference. Does that make sense? Are all of my samples going to give me a 6% difference? No. Why? What did you yell at me at before? Random sampling variability. Each sample changes. Maybe you get one sample that had a lot of women and very few men. Maybe you have another sample where they're exactly the same. Maybe you have another one where they're even more different than you thought. Samples change from group to group. And this says, of course, sampling error means the poll won't reflect the difference perfectly. What is the standard deviation for the difference in proportions? Using the formula that we were talking about, I want you to write down, calculate it, tell me, what would the standard deviation for the difference in proportions be? And we are saying standard deviation here because I am giving you what's true about the proportion or about the population. Okay, so write down your formula. Come on. Werk, signora. Red pen does not like my board. Okay, I'm going to show you the way that I would do this in a problem. My P is the proportion with a favorable impression of the candidate or whatever. And I have my two groups. I have my men and my women. Why am I saying P's and not P hats? That's the true value. Obviously, you don't know this, but this is the true value. So because that's the true value, I am using P's, not P hats. You got to keep that straight. And then if that's P, what would Q be? One more time. 0.41. And what would Q be for the women? 0.47. How many men were there? How many women were there? Okay, is that pretty clear as to what I've got? Everyone fine with that? So I have my bits and pieces. I have my proportion identified. I can check my assumptions and conditions. Tell me an assumption I need to check or condition. One more time. Independence. So what about the proportion with a favorable impression? What can I say? I'm just going to say feelings should be independent. And I'm going to do it across both. I'm going to say in both groups. Because that'll cover it for both of them. In both groups, the feelings should be independent. What else do I need? 10%. So I'm going to say, and it just so happens that we've got 300 for each group. So I'm going to say 300 should be less than 10% of all males and all females. Look, I've just done it for both of them in one sentence. So I've got independence, I've got 10%. What else do I need? Success, failure. So for success, failure, what do I need to do? .59 times 300, 0.41 times 300. And then I'm going to do the same thing for the women's. I'm going to do 0.53 times 300. And I'm going to do 0.47 times 300. So come on, you guys have calculators. You've got this. This is an easy button to hit. Round it out to the nearest tenth for me. What is 0.59 times 300? Can you even hear what he's saying? Was it exact? No, she was sitting right next to you if she was. So we have 177 here, and we have what here? 123. Good. And then over here, what am I going to have? And what's true about those? All are greater than 10, so I can say large enough. And there's one more. What else do I need? Random. Well, we've got feelings should be independent. We are told random sample. And because we have a random sample, what else should I have? What needs to be true? Independent groups. So the random sample gets me the fact that the feelings should be independent and that the groups themselves should be independent. The feelings should not affect each other. And because of this, with all of this said here, we are going to say that my sampling distribution follows a normal model that we would expect. And what did we say we would expect? 6, because that's coming from 0.59 minus 0.53. And what should the standard deviation of that be? Well, I'm going to write out the formula. And you can either, in this case, do PM QM over NM plus PW QW over NW, because I have all of those things listed out. And what would you say that that is equal to? Can you give me a decimal for that? 0.0405. Let's just, because we're going to have to draw this for the next step, let's leave it at 0.04. Do you guys see what I've done so far? Now you're going to see why I just write the bits and pieces up here. The next thing, Lord, I just am special today. It says sketch a sampling model. What would this sketch look like? A normal curve. Yeah. So to sketch this guy will look like a normal curve centered where? 0.06. 1, 2, 3, 1, 2, 3. What would this be? 0.1, 0.14, 0.18. What would this be? 0.02. What would this be? Negative 0.02. And what would this be? Could you have a difference be negative? Yeah. And that's why for this, it's very important that you specify difference in proportion of favorable impression and what do I need to do here? Male minus female. Because this isn't like talking about a proportion of men, where no, you cannot have a negative proportion of men. But this is a difference. And if my numbers end up being negative, What does that mean about the proportion of males minus females? I'm sorry? Yeah, more females have that favorability. And when you're drawing your proportion, you want to make sure that you either do your 68, 95, 99.7, which is all I'm going to do. 68, 95, 99.7, or you do all of those little bits and pieces. And guys, I want to show you something. And then you can groan, if you're not groaning already. Sampling distributions, proportions. This here, display and describe. And the very first part that we used was collecting data. We have so far shoved and covered every single aspect except for the probability unit that we have done this year. And actually, with this formula, we can even say that we've done the probability unit. Okay, that old stuff does not die. Now, the next part said, could the campaign be misled by the poll, concluding that there really is no gender gap? Based on this, what's actually true, do you think it would be reasonable to have a conclusion that there is no gender gap? Oh, freaking glorious. So here we have 2 standard deviations. Okay? That's what my 95% confidence interval would show. What falls in that? Here's 0. That's the null. That there is no difference. Do you see what I'm talking about here? The poll could be misleading. Because, and if I were to guesstimate that, I don't know, actually not a guesstimate, it's perfectly, I would say 0% or no difference is now spelled O-L-N-Y. Only 1.5 standard deviations away. Or the truth. Does that make sense what we've got going here? There's a lot in this mess, isn't there? Okay. All right, so kind of getting down to the nitty-gritty. Again, this is not really going to change anything. This is what I just showed you. When we're talking about our sampling distribution for these guys, it's going to be centered at whatever your observed difference is, and the standard deviation is going to be with whatever that formula was. And so if I'm talking about a hypothesis test, I'm going to use the null hypothesis. So what is typically my null hypothesis going to be when I'm looking at difference of 2 groups? 0. So you will use a 0 for that difference. Some other things also change. So when we're talking about our 2 proportion Z interval, our Z interval still has, I want you to understand, guys, this is still the same thing. Observed difference. P1, P2. Plus or minus. Test statistic. Exact same policy to follow. How do you find your test statistic? Inverse normal. Times the standard error, which is just same thing as standard deviation using P hat and Q hat. Okay? It's just that now our observed plus or minus test statistic times standard error, it just tweaks a little bit with those formulas. And you know what, guys? That's not going to change. It's always going to follow that same pattern. This little guy will change a little bit, this little guy will change a little bit, and this little guy will change a little bit. Okay? And Z star comes from your confidence level that you specify. You guys having fun yet? You look so excited. Everyone then immediately looks at the clock. How long do we have to put up with this crazy woman for? Let me see here. How much longer? You have about 10 more minutes with me. You can do it. All right. Read-a-ma-jig. I don't know what that means, but I said it anyways. We're going to get through at least this problem. Yes. What should you do first? Even before the assumptions and conditions. Identify P, identify your groups, identify your bits and pieces. So let's go. Let's go ahead and start going over this. So the very first thing that you needed to do was you needed to identify that P is the proportion of Americans with a high school diploma. And it's up to you whether you said M is men and W is women. That's one of those that are kind of understood to be, if you use M and W, then they'll know what they're talking about. So you wouldn't need to define those. You do need to tell me what order you're going to go in someplace. I don't care where it is, but I need to be able to see it. So I've got my conditions. Both samples were random, and men should be independent of women. So boom, I've covered both independence within my group and between groups. 10%, and you notice here both of those are two different sample sizes. So I've listed those both. And I didn't show you my formulas, but I wrote down what NP, NQ, NP, NQ were for both groups. All of those numbers were bigger than 10, so it's large enough. My sampling distribution, you can see here, I said this is my order, men minus women, and there's my formula. You still need to show your Z star. For your confidence interval, you have a choice. You can either write all that stuff out in a formula, or you can just write the formula. Because no matter what, hopefully your calculator gave you that. Did your calculator give you that? Those numbers? So then my interpretation would be that we are 95% confident based on our sample. The true difference in proportion, men minus women, of those with a high school diploma, lies in the interval from negative 4% to negative 2.4%. What does that mean if I'm looking at that? If I did men minus women and the whole interval was negative, there's more women. So ladies and gentlemen, your homework for tonight is your My Math Lab that will be due on Thursday. Yay, ladies. Women. Thank you guys. I hope you have a great day.